Here are two men trying to move a boulder. Both of them are applying a force along the line of the ropes that they are pulling. The forces exerted by the two men on the boulder can be equated with two vectors A and B inclined to each other at an angle theta. Vector multiplication is of two types. One is dot or scalar product, and the other is cross or vector product. The name itself indicates the result. If we use scalar product, the result is a scalar, that is, a real number. If we use vector product, the result is a vector. You will now learn to find the scalar or dot product of two vectors. Let vector A and vector B be two non-zero vectors. The scalar or dot product of vectors A and B is denoted as shown and is defined as the product of the magnitudes of vectors A and B and the cosine of angle theta between them. The range of theta is from 0 degrees to 180 degrees. If either vector A or vector B is a zero vector, then angle theta between them is not defined, and hence their dot product is 0. We know that the magnitude of any vector is a real number and that the cosine of angle theta is also a real number. Therefore, the product of the magnitudes of vector A and vector B and the cosine of the angle between them is a real number. Hence, we can say that the dot product of any two vectors is a real number. Suppose vector A and vector B are non-zero perpendicular vectors. Therefore, the cosine of the angle between them is 0. Hence, their dot product is 0. The converse is also true. Suppose vector A and vector B are non-zero vectors such that their dot product is 0. Then, the two vectors are perpendicular to each other. When vectors A and B act along the same line in the same direction, the angle theta between them is 0. In this case, the dot product of vectors A and B is equal to the product of their magnitudes. If the magnitude of vector A and the magnitude of vector B are equal, then their dot product is equal to the square of the magnitude of vector A. When vectors A and B act along the same line in opposite directions, the angle theta between them is 180 degrees. In this case, the dot product of vectors A and B is equal to minus times the product of their magnitudes. This implies that the dot product of a vector with its negative vector is equal to the square of its magnitude with a minus sign. If the magnitude of vector A and the magnitude of vector B are equal, then their dot product is equal to minus times the square of the magnitude of vector A. If the magnitudes of two non-zero vectors and their scalar product is known, you can find the angle theta between them. The dot product of two vectors is commutative. The properties of dot products that we have discussed so far give some very interesting results. You have studied unit vectors I, j and k along the x, y, and z axis, respectively. The dot product of unit vectors I, j, and k with themselves is equal to 1. This is because each of these unit vectors has a magnitude of 1 and angle theta in this case is 0 degrees. The product of any two of the mutually perpendicular unit vectors I, j, and k is 0. This is because angle theta in this case is 90 degrees.